we derive the expression for energy, we derive the expression for radius, velocity, kinetic energy, potential energy, and total energy, and then energy level diagram. That part we have finished. So our expression for energy was this much: Z square over N square, Me4 8 epsilon naught square H square. We always recall by this way, and E naught is this much, 13.58, or it may be approximately 13.6 electron volt. An energy level diagram, that is the diagram representing the energy of electron revolving in different orbit. That is the meaning of energy level diagram. So today we shall see the line, emitted line or absorbed line of hydrogen spectrum. So about hydrogen spectrum. So what was the assumption of Bohr? Bohr assumed that till the electron is revolving in any orbit, there is no change in its energy. But once it goes from higher orbit to lower orbit, it will emit energy. And if the same amount of energy what it can emit while jumping from higher to lower, if same amount of energy it absorbs, then only it will jump from lower to higher. So we will calculate what will be the wavelength, what will be the frequency, and then new term will come, that is wave number. And then we will discuss the spectrum. So if electron jumps from orbit N1 and equal to N1 to orbit N equal to N2. We are taking this N1 is less than N2, or from N2 to N1. So in this case, what will be, when it is jumping from higher to lower, energy will be emitted. When it jumps from lower to higher, energy will be absorbed. So whatever difference in this energy will be, when it is revolving in first orbit, suppose this much energy, once it goes to second orbit, 1/4 of this will come. So whatever that difference in energy is, that is the energy either absorbed or energy emitted. So energy absorbed or energy emitted by electron. This delta E will be so this is E and 2 minus E and 1. While jumping from higher to lower, energy emitted. Going from lower to higher, energy absorbed. When it is absorbing energy, naturally final will be more than initial. If it is losing energy, initial was more than final. So in all both the cases, this one will be there. That is energy corresponding to higher orbit minus energy corresponding to lower orbit. as the remaining things are same. For hydrogen it will become Z equal to 1. So it may be Z square over N square, sorry, Z square Me4 over 8 epsilon naught square H square. If we are taking minus sign here, 1 by N2 square minus 1 by N1 square. If minus sign is going inside, N1 minus N2. So it is Z square Me4 8 epsilon naught square H square 1 by N1 square minus 1 by N2 square. This is delta E. So whatever energy is emitted, that will be in the form of photon energy packet. So this, since this delta E is h nu, so frequency of emitted sorry, h nu, or it can be hc over lambda. This nu will be delta E over h. So one more h will come here. So Z square Me4 8 epsilon naught square h cube. So what will be the wave number? This mu bar is equal to 1 over lambda. That means how will you find 1 by lambda? So 1 by lambda means delta E over hc. So delta E over hc, delta E over h is this one. So one c will also come. So it is Z square big mistake here. It will be, that will 1 by N1 square minus 1 by N2 square will also come. That we forgot. So Z square Me4 8 epsilon naught square CH One by lambda means number of waves per unit length. That is the wave number. Number of waves per unit length. That is, in 1 centimeter, how many waves will come? Or in 1 millimeter, how many waves will come? Or in 1 meter, how many waves will come? That is wave number. So here frequently we use this term. That's why we have used this one. Now, this all are constant from here to here. And this constant we call Rydberg constant. So this is Rz square 1 by N1 square minus 1 by N2 square, where this R is Me4 over 8 epsilon naught square CH cube is known as Rydberg constant. and this R is 1.097, I think. So what will be the unit? 1 by lambda per meter. So it should be also per meter because this is the number. So per meter or meter minus 1. That is in 1 meter, this many waves will come if the remaining thing is 1. Z is 1, 1 minus n1 square minus 1 by n2 square is also 1. Then this many waves will come in 1 meter. That is the Rydberg constant. So this is, suppose you are asked frequency, then we will use this formula. If wave lambda, that is 1 by lambda, so nu bar or 1 by lambda is this much. Now this formula we will use to explain the different spectrum of hydrogen atom. So first is Lyman series. For hydrogen, this Z will become 1. So we can write this one. For hydrogen, for H atom, what will be? This nu bar or 1 by lambda will be R 1 minus n1 square minus 1 by n2 square. This is Z is 1 here. Now in Lyman series, what happens? Electron jumps from any higher orbit to first orbit. That is emission 1. Lyman series of absorption spectra, electron will absorb some energy and will jump from first orbit to any other orbit. That is the difference between emission and absorption. So Lyman series. So in this case, what will be? For emission line, electron will jump from any higher orbit to first orbit. For absorption line, what will be? Electron in ground state, that is first orbit, we say ground state. Will absorb energy and will jump to any higher orbit. That means for Lyman series, whether it is emission or absorption, delta E will be same, 1 by lambda will be same. Whether it is emitted or absorbed, that is, you have to calculate. That is, for this series, what will be? N1 will be 1, that is fixed. Either it will jump from higher to first, or it will jump from first to any higher. So N1 will become 1 and this N2 will become 2, 3, 4 or any other higher maybe. So if it is jumping from first to second, the energy difference is the minimum one. Minimum difference means minimum frequency, minimum energy means minimum frequency. and maximum wavelength. So for minimum frequency of Lyman series, electron will jump from first to second. Or from maximum wavelength of Lyman series, electron will jump from first to second. Or we call it first member of Lyman series. So what will be in this case? This 1 by lambda will become R 1 by 1 or simply 1 minus N2 square, and N2 will be 2, 3, 4 like this. For first member of Lyman series, that is for minimum frequency or maximum wavelength of Lyman series. What will be? This N2 will be 2. So 1 by lambda 1 will come how much? So it is R 1 minus 1 by 4. That means this lambda 1 will be 4 over 3R. How much the value will come? For second member, what will be? One by lambda 2 will become R 1 minus 1 by 9, 3 squared will come. That means this lambda 2 will become 9 by 8 R. How much? It is 1453 angstrom or 145.3 nanometer. Here it will come 126.6 nanometer. Now similarly, if we keep on increasing, it may come like this, first, second, third, fourth, like that. Now the series limit of Lyman series. For series limit, what will be? The electron is either jumping from infinity to first orbit, or it is going from first orbit directly to infinity. That is maximum frequency and minimum wavelength. First member, minimum energy, minimum frequency, maximum wavelength. And here it will be maximum frequency or maximum energy and frequency. Energy of photon maximum, that is series limit. So you are asked, what is the maximum energy of the photon emitted by Lyman series? That means indirectly you are asked the energy of series limit. So what will be in this case? 1 by lambda L will become R 1 minus 1 by infinity square. So lambda L will be 1 by R. How much will come? 900 something will come. 91. So 91.2 nanometer. So all the members of Lyman series are in UV region. So these lines will not be visible. 22.3 nanometer. 122.3 nanometer and the rest 032. So 103.2 region. So they are not visible. Now what is the next possibility? The electron may either jump from higher orbit to second orbit, or it may go from second orbit to any other higher orbit. And the series corresponding to this transition we call Bohr series. So second member is Bohr. So second is Bohr series. So in this series, electron will either jump from higher orbit to second orbit, or will jump from second orbit to any other higher orbit, that is emission or absorption. So in this case, this N1 will be 2 and N2 will be 3, 4, 5 onward like that. So what is the first member? So first member of Bohr series. Or for first member of Bohr series, what will be? N1 will be 2 and N2 will be 3. So 1 by lambda 1 will be R 1 by 2 square, that is 1 by 4. So this is 36, 5. That means this lambda 1 will be 36 over 5R. 6.60.
5. Yes, sir.
10 to the power minus 7.
Yes, sir.
So it is 660.5 nanometer. In which region it is? 4000 to 8000 or 400 to 800 is visible region. So it is in visible region. So this is visible region, that is, it will appear as red light. That means from the hydrogen light, if you are taking in place of halogen light, hydrogen light, so one red line also you will be visible. This we call H alpha line. This may be in red region, you can say, or orange region will be, no, it is red region only, 650 onward. So this we call H alpha line, it has got fixed name. For second member, what will be? How much it is? 9.2 nanometer. This is also in visible region. This light will appear like in blue region, we can say. So this is also in visible region. This we call H beta line. So,
Yes, sir.
how much? 368. So 436.8 nanometer. This is also in visible region. This we call H gamma line. Fourth member will come 1 by 4 minus 1 by 36.
One to 8. Yes, sir.
This is also in visible region. This we call H delta line. So these four lines are in visible region. So electron may jump from third orbit to second orbit. Then this one will emit. For other atom, maybe suppose in halogen light or hydrogen light we are seeing halogen lamp, many hydrogen atoms are there. So for one atom, electron may jump from fourth to third, fourth to second, someone in that other case fifth to second. So these lines will be visible in the spectrum when we pass through the prism. These four regions or four light or four different color will be visible. So this is violet region maybe, or these all three will be in this blue region. Only one will become in red region. Now for series limit, what will come? 9 nanometer. That means four members are in visible region and rest are in ultraviolet region. So four members of Bohr series are in visible region and the rest are in ultraviolet region, UV region. So sometimes we ask, name the series in which a few members are in visible and rest others are in invisible region. Or name a series which has got both the type of members, visible and invisible region member. In chemistry you have done, no? So Lyman, then Bohr, after that Pasteur. So in this what will be? Either electron will jump from third orbit to any higher orbit, or from higher orbit it will come to the third orbit. That is it already in excited state. Second orbit means excited state. First orbit, that is ground state for hydrogen. Normal state, electron will revolve in first orbit only. So first excited state means electron is present in the second orbit. So for that we have to give some energy. Then only it will go to second orbit. Okay, in case of Pasteur series, what will be here? N1 will become 3 and N2 will be 4, 5, 6 onward like that, up to infinity you can say. So here we will calculate first member and then series limit because all are in same region. Only in Bohr series we have to know all four wavelengths. So for first member, or 1 by 9 minus 1 by 16 minus 6, that is 1887 nanometer. So in which region it is? 400 to 800 visible. Above that, which region? Infrared region. Now series limit, where all the members are in infrared region. So series limit will be 9 over R. 2, 5, 6.
Yes, sir.
Okay, so 825.6 nanometer. All the members are in infrared region. So suppose you are asked, name the series of hydrogen atom that lies in infrared region. So that is Paschen series. Similarly, others are bracket and P fund. You might have done in chemistry. So for bracket series, what will be? Same way you can calculate. N1 will be 4 and N2 will be 5, 6, 7 onward. For P fund, N1 is 5 and N2 is 6, 7 onward, like that. So these are the different series. We can calculate the wavelength. So these all are in infrared region only. Ultraviolet region, all the members ultraviolet, Lyman series. Some are ultraviolet, some are visible, Balmer series. All infrared, that is Paschen series. And these all also infrared region will come. Now, how will show this spectrum on energy level diagram? Sometime you will be asked, draw the energy level diagram, and on your diagram you show first three member of Balmer series, or first three member of Lyman series, or first three absorption line of Lyman series, or emission line of Lyman series. Then how will you show it? So suppose this is our n equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5, n equal to 6, okay, and this is our series, n equal to infinity. So this is 0, energy in electron volt, minus 13.6, minus 3.4. What are the values you are doing? So it is 1.51, 0.8 something it was there. So all values you have to write. Now, if you are asked to show the first three emission line of Lyman series, then what will be? One transition you will show like this. This is the first member, this is the second member, and this is the third member. And from this one, if you are taking, then this one we call series limit. This is series limit. Emission. This is first member, this is second member, this is third member. So this is Lyman series. Emission line of Lyman series. Okay. Absorption means arrow mark will be opposite. Absorption line means it is going from first orbit to higher orbit. First to second, first to third, first to fourth, first to fifth, like that, and this will be the series limit. When electron when electron absorbs the same amount of energy, what it can emit. Suppose here it is coming 10.2 electron volt. So if electron absorbs 10.2 electron volt, then only it will jump from first orbit to second orbit. Here suppose the difference is coming 12.1. So when electron absorbs 12.1 electron volt energy, it will directly jump from first to third. It will not go to the second then. So whatever energy difference of these two levels will be, if an absorbed amount of energy is the same, it will jump to that orbit only. So that is Lyman series. Now suppose you are asked Balmer series, then what will be? This is our H alpha line. This is H beta line. This is H gamma line. This is H delta line. And this is our series limit of Balmer series. This is all our emission line. This is series limit. Absorption, just reverse. From second, it will go to the third. Second, it will go to the fourth. Second, it will go to the fifth, sixth, and then this one will be like that. This one again, H alpha line. That is energy absorbed. Whatever wavelength is emitted, same wavelength will be absorbed. That is energy corresponding to that particular wavelength. If it is absorbed, it will go to the from second to third. So these are the absorption line. Lyman, Balmer, Paschen, bracket, P-fund, whatever it is asked accordingly. Generally, these two are asked, either emission or absorption. Sometimes you will be asked two emission line of Lyman and three absorption line of Balmer. Then on the same energy level diagram, we have to show both. Emission line means arrow mark down, absorption line means arrow mark up.